first thing we did was open our Canvas to access the PhET simulator. Canvas has a circuit construction kit, DC that can be accessed. And the next step we did was to construct the parallel connected resistance circuit with the required instrument, 2 voltmeters, 2 resistors, 3 ammeters, wires, battery, and a switch. We then click on the resistor and input a random value. This will be its resistance, which was repeated for another resistors. We attach the probes of 1 voltmeter to the end of the one resistor to determine its voltage, and repeat with the other voltmeter and resistor. Next, we attach the probes of 1 voltmeter to the opposite angle of the circuit to get the complete voltage. Then, we flip the switch.
For the first trial, we use the resistance of 15 and 25 ohms as R sub 1 and R sub 2 respectively. For the second trial, we use 20 and 25 ohms as R sub 1 and R sub 2 respectively. And finally, for the third trial, we use 25 and 30 ohms as R sub 1 and R sub 2 respectively. Sequentially, we use ammeters and voltmeters to measure the current and the voltages. Our battery was set at 25 volts. We recorded our data in the tables to be analyzed. We then used the formula computing the total resistance. For the first trial, as shown here, we arrived at a total of 8.57 ohms. For the second trial here, we arrived at 11.11 ohms. And lastly, for the third trial, which resulted at 13.64 ohms. All of the information gathered was tallied and in our table and then evaluated.
Resistors are in parallel when each resistor is connected directly to the voltage source by connecting wires having negligible resistance. Each resistor should possess the full voltage of the source applied to it. Parallel resistor network the circuit current, which can take more than one path as there are multiple paths for the current. Thus, parallel circuits are classed as current dividers. Since there are multiple paths for the supply current to flow through, the current may not be the same through all the branches in the parallel network. However, the voltage drop across all of the resistors in a parallel resistive network is the same. Then, resistors in parallel have a common voltage across them.
Major features of resistors in parallel are the following. First, parallel resistance is found from, and it is smaller than any individual resistance in the combination. Secondly, each resistor in parallel has the same full voltage of the source applied to it. Power distribution systems most often use parallel connections to supply the myriad devices served with the same voltage and to allow them to operate independently. And lastly, parallel resistors do not each get the total current. They divide it.
As observed in our data, the total resistance in a parallel circuit is equal to the sum of the inverse of each individual resistances. This is all observed from our 3 trials. Furthermore, the voltage is equal across all components in the circuit. And lastly, the total circuit current is equal to the sum of the individual branch currents.
For our analysis, the actual amount of current always varies inversely with the amount of overall resistance. There is a clear relationship between the resistance of the individual resistors and the overall resistance of the collection of resistors. This is the concept of equivalent resistance. The equivalent resistance of a circuit is the amount of resistance that a single resistor would need in order to equal the overall effect of the collection of resistors that are present in the circuit. For parallel circuit, the mathematical formula for computing the equivalent resistance is 1 over resistance is equals to 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3, where resistance 1, resistance 2, and resistance 3 are the resistance values of the individual resistors that are connected in parallel.
We conclude that for resistors in parallel, the overall resistance is the reciprocal of the sum of reciprocals of the individual resistor. Total resistance in a parallel circuit is always smaller than the smallest individual parallel resistor.